This is GATE 2022 Life Sciences, Section S Microbiology, question number 78. The correct sequence of overall biochemical reaction which expresses the process of denitrification is dash. Okay, these are the different states of denitrification. In denitrification process, we have generation of N2. This is the NPTEL online course reference. So what is denitrification? So denitrification is nothing but reduction of NO3 minus. So HNO3 is, so denitrification, we have the terms like denitrification and we have terms like nitrogen fixation. Okay, so what is denitrification? In denitrification we have NO3, conversion of NO3 minus. NO3 is nitric acid, okay, HNO3. Okay, this is the most oxidized form of nitrogen. So nitrogen here, the nitrogen which has so nitrogen has electron 7 electron, right, and the atomic weight is 14. So HNO3 here, the nitrogen is in the most oxidized state. Okay, so from most oxidized state to most reduced state, N2 is most reduced state. Okay, and this process from oxidized to reduced is known as denitrification. So as you can see here, we have NO3 minus and it is getting reduced to, this is elemental nitrogen. Okay, this is elemental nitrogen. This is the most reduced state. Okay, from oxidized to most reduced state is known as denitrification. Okay, fixation, it is very simple. From elemental nitrogen, this is very important, this N2 is known as elemental nitrogen. So from elemental nitrogen it is fixed to ammonia, right? Many bacterial species like rhizobium, they fix ammonia for the plants. So this nitrogen fixation into ammonia is known as, so this is known as nitrogen fixation, where elemental nitrogen is fixed to, it is converted to ammonia. Okay, then we have other processes like ammonifications and nitrification. Okay, so nitrogen fixation is nothing but conversion of elemental nitrogen to ammonia, and nitrification is conversion of oxidized nitrogen to elemental nitrogen. Okay, so it is very important to understand. So they have asked the denitrification process. So in order to answer this question, okay, what is the correct sequence of the overall biochemical reaction in the denitrification process? So in order to answer this question, you no need to remember the overall nitrification process. You just need to remember that from most oxidized nitrogen we get to elemental reduced form of nitrogen, right? And from, so this process is denitrification, and from elemental nitrogen to highly reduced form, this is the highly reduced form of nitrogen. This process is nitrogen fixation. Okay, you don't need to remember all this pathway. You can just simply calculate the valency of nitrogen and find out which is more reduced and which is not. Okay, so how to find out the valency of nitrogen? This is very simple. So at first we have 2NO3 minus. Okay, 2NO3 minus. How calculate the valency of nitrogen? It is very simple. We just have to ignore this 2 here. We have to ignore this 2. So we have NO3 minus. Okay, we know the valency we know the valency of oxygen, it is -2. Okay, we know the valency of oxygen, which is -2. So so the valency of nitrogen will be X -2 3 times, because we have 3 oxygen here, -2 3 times, and the overall charge is negative, so it will be -1. This is how you calculate the valency of nitrogen. So the X will be, the valency of nitrogen will be +5. Okay, the valency of nitrogen will always be in plus, whereas the valency of oxygen will be in minus, because it is more electronegative. Nitrogen is more electropositive in NO3 minus. Okay, so NO3 minus has a so nitrogen in NO3 minus has valency of +5. Okay, so next is 2NO2 minus. So here also just ignore this 2. We can calculate this as -2 into 2, because we have 2 O2 is equal to -1. So the valency here is +3. Okay. So always remember, in the denitrification process, from the most oxidized state, it will go to the reduced state. So the oxidized state will have a higher positive. It will have a higher positive charge, and slowly the valency will reduce and it will become 0. The overall valency of nitrogen will become 0 in the elemental form. Right? In the elemental form it will be 0. And in ammonia, what will be the valency? It will be minus, how much? -3, right? -4, sorry. In ammonia, the valency will be -4. So in the reduced state, it will go to negative. The valency will go to negative, whereas in the oxidized state, it will be from positive. So valency will go from positive to negative, like as it is getting reduced. Okay, very simple. Then we have N2O. So the valency of nitrogen here will be 2x -2 is equal to 0, because there is no charge here, so it will be equal to 0. So X will be +1. So N2O will have +1. And then finally we have NO, right? We have NO. So here the valency will be X -2, right? X plus X minus 2, which will be X is equal to 2. So if we want to rearrange this based upon the most oxidized to reduce, it will be NO3 minus 2NO2 minus, right? Then we have NO, right? And then we'll have N2O. Okay, and elemental nitrogen will always have valency 0, right? The elemental nitrogen will always have valency 0. This will be 0. Sorry, here this will be N2, right? So the valency of nitrogen can vary from +5, okay, +5, then we have +2, then we'll have 0, then it will go to negative. As it will get more reduced, the valency will be negative, and finally we'll have -4 valency. Okay, so nitrogen, the valency will go from +5 to -4. In -4 state, the nitrogen will be most reduced, whereas in +5 state, the nitrogen in case of NO3 minus or HNO3, it will be most oxidized. Okay, so this is the denitrification process. So you can just calculate the valency and decide how to place this pathway. Okay, how to rearrange this nitrogen denitrification pathway. Okay, you no need to remember, also just based upon the valency you can decide. So here, So here we have a denitrification process. Okay, so this denitrification process we have from NO3 minus to elemental nitrogen. Okay, this process from conversion of NO3 minus, that is most oxidized form of nitrogen, is converted to elemental nitrogen. This process is known as denitrification. Whereas elemental nitrogen to ammonia to reduced form, it is known as nitrogen fixation. To calculate the valency, it is very simple. So in the question we have 2 NO3 minus. Okay, so this NO3 minus is nothing but HNO3, nitric acid. Okay, so how to calculate the valency? We have to ignore this 2. Okay, this 2 is of no use. So valency of nitrogen, let's consider it as X. Oxygen, we already know that the valency is -2, right? We should know the basic valency, like oxygen has -2 valency. It will always have -2 valency. Okay, hydrogen will always have +1 valency, right? And all the halides will have -1 valency, right? So -2, we have 3 oxygens, so -2 into 3. Okay, X plus -2 into 3, right? Remember this plus sign. And the overall charge on NO3 is -1, since there is no H. If there was H, what it will be? So hydrogen valency will be +1, plus nitrogen we don't know, plus oxygen is -2 into 3, and the overall charge is 0, so we will equate it to 0. Here the overall charge is -1, so we are equating to -1. So this will become X plus, so this will become plus, this will become -6 -1, so X will become +5. Is this clear? So the valency of nitrogen in NO3 minus is +5. Is it clear now?
Yes, ma'am.
Similarly, if we have NO, then it will be X plus -2. Valency of oxygen is -2. Since overall charge here is 0, we will equate it to 0. So X will be equal to 2, +2. So the valency of nitric oxide is +2. Okay, so in denitrification process, we have the most oxidized to elemental will have, which has the 0 valency, to most reduced. Okay, so here we'll have a highest positive a nitrogen can go is +5. So it has total 7 electrons, right? 2 are in the first orbital, and in the second orbital we have 5 electrons, right? 1 2 3 4 5. So nitrogen can lose all 5 electrons and it can acquire +5 of valency. Okay, so this process is known as denitrification process, from oxidized to elemental nitrogen, and from elemental nitrogen to reduced, this is known as nitrogen fixation. Okay, very simple. So from +5 valency it goes to 0, and then finally it goes to -4. -4 is ammonia, NH4 plus, sorry, -3. NH4 plus is ammonia, right? So here the valency will become +1 is equal to 1. 1 minus 4. Yeah, so the reduced state is -3. Okay, so nitrogen can go from +5 to -3, right? It has 5 electrons. It can lose all 5 electrons and get oxidized completely in NO3 minus, or it can gain 3 electrons, right? It can gain 3 electrons and it can complete its valence shell, right? Valence shell can be completed. So it has already 5 electrons. It can gain plus 3 electrons and can complete its 8 electron and it complete its valence shell. So the valency of nitrogen is from plus 5 to minus 3. Okay, this is how you calculate the valency. And coming back to the question, so we already calculated this. So the valency of NO3 minus is 2NO3 minus is what? Plus 5. Then we have NO2 minus, 2NO2 minus, the valency is plus 3. You can calculate this by yourself also. N2O valency is plus 1. NO valency is plus 2. Elemental is always 0. Okay. So if you can arrange this, right, so if you can arrange this, it is matching with the option B, right? Plus 5, plus 3, plus 2, plus 1 and 0, right? So this is the denitrification process. This is the process of denitrification. Okay, this is the overall biochemical reaction.